Okay, pause the question or pause the video and read the question. Go ahead and try to draw out your own picture of this and think about it on your own first. Okay, hopefully you've done that. So I would draw this picture here in the XY plane. I would draw my ladder here. And what I'm told is the ladder is sliding down the wall. So this point down is moving down at 2 feet per second. I want to know then how fast is this little spot, question, moving at some moment at the time when this distance is 5. So we'll call this distance here X, that distance Y. I don't know what time it is. Notice I didn't write T equals 5. But there's some moment in time, and literally, I'm never even going to find it. But there is some moment in time when X is 5 feet. So I want dx dt, the rate of change of X when X equals 5. And I'm given that dy dt, this rate of change, is negative 2 feet per second. Why negative? Because Y is decreasing. Y is this distance here, and that's going down. So a decreasing function is a negative derivative. See, X is increasing. I'm going to end up with a positive answer here. This X is getting bigger. We're figuring out how quickly this point, the bottom of the ladder, is moving. And that's 5 feet right there. Okay, so it's a related rates problem. We've drawn a picture. We've defined all of our variables. Now we got to somehow find a relationship between these variables. Well, I know this side doesn't change. That's the length of the ladder. That's a right triangle. My goal here on every related rates problem, find a formula that relates your variables. Draw a picture, introduce some variables, you might have a bunch, and then find any equation that relates them. Usually there's only one, but how do these relate? By Pythagorean. X squared plus Y squared equals 10 squared. So I've related X and Y. Now I got to relate the derivatives. And we do that every single time by taking some derivative. And it's like, I can't think of a single related rates problem where we're not taking the derivative with respect to time. Time is almost always our independent variable. So I'm going to note here that X is a function of time. Y is a function of time. That's what this notation means. I'm telling the reader X is X of t, Y is Y of t. And then we use implicit differentiation. So the derivative of X squared is 2X times the derivative of what's inside. What's the derivative of X? Dx dt. Don't use primes. Plus, derivative of Y squared will be 2Y times dy dt. And then a lot of times people make this harder than it needs to be. The derivative of a constant is 0. That side doesn't change. So, like, I could do a little cleanup here. I could divide everybody by 2, move this to the other side. I could say dx dt will be negative y over x times dy dt. So check my arithmetic there, my algebra. I move this to the other side. I got y. Those are together. Those have to move together. And then I divided both sides by x to get this guy by itself. And this is who I'm after. That's what I want when x equals 5. But notice here, so I can't just plug in x equals 5. I don't know why. I need, and a lot of times you don't realize this until you get down to this point. You're like, oh, darn it, I need something else. So I note here, I need y when x equals 5. Because x and y are changing at the same time. So let's draw a little picture here. This side is 10. At the moment when this is 5, how would we get this? We do Pythagorean. So maybe, let me just call it y. Y squared plus 5 squared will be 10 squared, 100. I think you'll believe me when I just jump to y is square root of 75. So again, that's not always, that's at one particular moment in time. And notice I never found that time. I never say this happens at 2 seconds. I don't care about the time. But at some moment, x equals 5, at that same moment, y equals square root of 75. This side is going down at a constant rate, 2 feet per second down. That's why it's negative. I want to know how fast this edge is moving out at that moment. All right, so then dx dt, when, that's what this line means, evaluated at x equals 5 and happens to be when y equals square root of 75 will be negative root 75 over 5. dy dt was also negative because it was going down. And so we get dx dt will be positive. The negatives cancel. 2 root 75 over 5, whatever that is. And we need units here. We always need units. That was in feet per second. This is a rate of change. These will not all be velocities. If your guy on top isn't units of distance, then this wouldn't necessarily be a velocity, but this one is. That's distance per time. This is a velocity. We're finding rates of change. So like units are important here. And that's kind of ugly right there. That is a 5. Okay, that's a good place to stop on that one.